Good morning, everyone. That was an amazing backstory to this great conference by Gabe. So, yeah, excited to open up this amazing conference, which has treated me very well. I've spoken here a couple of years ago, so hopefully this one is better. I titled my talk, Use the React Platform, as a nod to the common thing every experienced web developer likes to say, which is use the platform, referring to using more of the web native primitives rather than reinventing everything from scratch. And today I want to show you real examples of what's possible once you embrace the newer primitives, or not so new anymore, that React brought us, and think of React as a platform to build upon. I'm JB. I'm a developer. I'm the founder of BaseHub. And BaseHub is a fast headless CMS. We focus on delivering a great developer experience. It's headless, and that's why you can use it with any framework. But we kind of especially focus and design for React. First, because I love it myself. And secondly, I really believe that it allows for deeper integration, especially paired with Next.js. Let's start with some context as to how the things I'll discuss in this talk came about. Before server actions and server components, I thought of React components as running solely on the client. Like, I assumed the regular component will run on the client. Or maybe that component will also run in the server, but thanks to SSR, but without access to it, like without access to environment variables, to the file system, and therefore without access to server-to-server communication with external systems. Server components change that. They can bundle code that will run solely on the server with its full power and context, and with the potential to send down islands of interactivity via use client. These client components then can communicate back to the server components via server functions or server actions. And so this was a key insight for me to understand, because it opened up a lot of doors for our product as we were building our SDKs and our developer tools. Because for a product like ours, this meant that we could deeply integrate with our users' applications just by exposing a React component. So over my talk, I'll do deep dives into some of these integrations and components that we built for our products and their users, just to give them a great developer experience and also a great editor experience, because our system is headless, meaning there are also editors that need to preview content, and we also need to satisfy developers with a great DX. We'll see that many of these features I'll talk about are quite complex. But after all that complexity, we'll see kind of a beautiful thing about React, which is all of that can be contained within the boundaries of a component. Our first deep dive is into a component we called pump. This is a server component that provides fast refresh or live preview for content. So this is kind of how it works. This is BaseHub on the left, and I open a preview of the website that's powered by BaseHub. And as I edit some of the content on the left-hand side, you can see that the website updates in real time. I can even go there, update the theme color, maybe update a logo, and everything should just update in real time, as you'd expect. Again, our system is headless, meaning users don't just point and click to edit stuff. They do so in a separate system, which is the one on the left. And that's why this feature was key to implement. Users or editors want to see instant feedback of their content as they make changes. We also needed to make it super easy for developers to integrate. Integrating it needed to be so easy and with as little trade-offs as possible, so that developers never second guess if they need pump or not. Is it hard? What are the trade-offs? Like, we work hard for having one import, one component, you're good to go. You never have to kind of second guess yourself. To get here, we tried many approaches. The first, maybe the obvious or the naive one we started with, maybe like thinking in this old paradigm before RSCs, was to start with a simple hook, call it use live query or use preview or something like that. And this hook would receive a GraphQL query. Our API is GraphQL, so it talks GraphQL. And this hook would subscribe to our API with that query and a WebSocket connection inside a use effect, and store the changes as they came in a use state. Then, in our page or any other component, we can use this hook and just render the data, except with this approach, we are kind of forced to use client on the top of every file that uses this hook or every component, which means we are already shipping this code to the client, meaning it's less than ideal to make stuff like syntax highlighting, markdown formatting, talking to an external API, all of those things that we probably want to do in our content pipelines. So this was not ideal at all. We kind of wanted something more like this, a server component that kind of awaited some query, then had that query down there just to use it, process it, whatever. Everything stayed on the server as much as possible, and then the result got sent down to the client. The obvious problem of something like this is that we lost the reactivity. We are not kind of subscribing and updating the content in real time, and so that's not good as well. One thing that we could certainly do was create a component, name it refresh router on content change, pretty verbose name, but the point of it is that it subscribed to the CMS with that query the way that the old hook did, and when a new change arrived, it ran router refresh from Next.js, kind of refreshing the whole page in terms of the data fetching. And this was actually the most decent approach we first landed with, but we weren't comfortable with rolling with it because router refresh just refreshes the whole thing. It's a bit blunt. Maybe it's a bit slower, we thought. Maybe you have other data dependencies that are running that will be running due to a content change. Content changes also may happen like really fast. You'll be editing a body of a blog post, and you'll maybe get 5 or 10 refreshes in just a couple of seconds. And back then, we also thought that if we put more of Next.js primitives inside our implementations, we'll be not stuck, but kind of building more for Next.js, whereas we wanted, I don't know if on our framework added support for React Server components, for it to just work. That hasn't happened yet, but it'll hopefully happen soon, I'm sure. And so our next iteration was the one we settled with, and it involved this seemingly weird combination of a React Server component and a render prop-like server function. So you run pump, you pass it the query, you kind of pass it like the old render prop paradigm, which is actually a server function as well. It looks a bit weird, but the idea was, okay, so for production traffic, meaning regular visitors, this would just run the function as a regular function, passing the data, or query it first, passing the data, and the JSX would just render and be returned there. So nothing crazy happened there. The server function just stayed on the server and was just like treated as a regular function. However, when team members preview content, pump would render a client component below it that would subscribe to the query, the same as we've seen in the old use live query hook, and call that server function every time it needed a new JSX by sending it the data as props. So essentially, receives new data in the client, calls the server function. The server function does the computation server side, returns some JSX. Honestly, I have no idea how we came up with this approach, just trying a lot of stuff, and it looks quite weird at first, but it works pretty well. So let's take a deeper look as to what's happening inside of Pump. So this is basically what Pump does. First, it queries the CMS for initial data. It calls the children render prop / server action to get the initial children, and it renders Pump client. It does so conditionally, but we'll see that later on. So in there, you have the initial children, and you can send down the query to the client for it to subscribe. Pump client, now in the client, it uses client. That's a lot of client words. But yeah, basically, it just, as I mentioned, subscribes to the query. As changes arrive, it kind of can compare if the query result changed. And if so, it refetches the children via that server function that gets sent down. The full implementation looks something more like this, with some enhancements meant for production, which is we have a parameter, we call it draft. It could be preview or something that tells Pump if the traffic or the thing that's calling this component is allowed to see draft content, or if it's just a regular visitor navigating around your website. And so if draft is false, we just return initial children. Nothing else happens. It's just, yeah. But if draft is true, we render the Pump client, and we wrap it in React Lazy, so the bundle just gets loaded if we know that the user is querying draft content, which means we have 0 performance footprint in the case for production traffic. But yeah, this got quite complex pretty fast, and there's a lot of things happening there. And that's yet another impressive thing about React, in that our developers don't need to really think about this. They just need to import and use Pump, and they're ready to go. And all of that complexity and all of the big words I talked about are just contained in that single thing. OK, so moving on to the next one. This one is Next.js specific, and it revolves around revalidating cached data. Next.js has this thing called ISR, in which pages get generated statically, and then the developer sets up a configuration in the revalidation strategy into how that cached data or those static pages will get revalidated once new data dependencies arrive. The developer chooses between time-based revalidation or on-demand revalidation. Time-based revalidation is super easy to set up. The dev just settles on a number that will define for how long that data will be stale, or actually the interval into which the data will be refetched and revalidated. The hard part about this is that if the dev chooses a number that's too high, say a minute or 2 minutes, then the content editors will press publish in their CMS, and will need to wait for a full minute or 2 minutes or whatever that number is until they see their changes live in their website, which is super tough. If the number is too low, like, for example, 1, which is the thing that I'd recommend if you were rolling with this, but the risk it has is that you'll be making more requests to your origin servers, potentially increasing your costs. It's just something that the developer is always trying to juggle and come up with the correct number. On-demand revalidation, however, is harder to set up. It involves setting up a route handler, authenticating incoming traffic, setting up a webhook on your CMS, saying, I need you to call this endpoint when this and this changed, when this and this other thing changed. Put in a secret there so authentication can happen. And kind of have your own logic of, yeah, if this change is of type blog, I revalidate the blog pages. If this is of type changelog, I do so for changelog pages. Sometimes for dynamic websites, it's hard to know which piece of content to revalidate. So you sometimes end up revalidating the whole thing, which is also not ideal. So it's a bit harder to set up. But it's much better once it's all set up there, because it means that as soon as your editor presses publish or commit or whatever, the changes should be live almost instantly in the next refresh that your editor does. So yeah, that's on-demand revalidation. It's pretty cool, and we wanted to facilitate setting up on-demand revalidation for our users with the same kind of mindset that we came for when we created Pump, which is very simple. The developer hopefully doesn't need to think about this. By default, everything should work like this in BaseHub. There's no 5 or 10 ways to set up this same thing. We recommend to use this flow, and it should all work, hopefully. So in this case, you need to import one component that's called toolbar. And to bring up our previous demo where we were making some edits, we were previewing it in real time using Pump. And we had those edits kind of not yet published to the production traffic. So down there in the toolbar, we removed the draft mode. And we can see the right thing is kind of where we started the website, how it looked before we made some edits. And we can go back to BaseHub on the left. We can commit or publish these new changes, add a commit message, and wait for it to commit. And as we refresh, the next refresh should hopefully get in that content already ready for us to see. So this should happen almost instantly. And so your content editors don't need to second guess, is this published? Is there an error? All of those doubts that come with the system being separate and being headless. Now, the way this works is it's really simple, although maybe it's quite verbose to explain. I mean, there's a lot of code in this slide particularly, but it's not that hard, honestly. We have our query client, which is the thing that Pump uses internally. It's the thing that actually fetches to our API with the GraphQL query. What it does is it generates a hash of the query plus the variables, and it uses next tags to essentially tag that query. Just put in that cache tag. And in parallel, it also sends that query hash to the server, to our servers. So our servers kind of store it. Once in our servers, the GraphQL endpoint receives the query, resolves it with the data that the user asks for, and stores a hash of the response data. So the query resolves to some specific piece of data, it hashes that specific piece of data, and it stores that hash alongside the original query hash. Now, when the content changes, or a commit happens, or a publish happens, our server will rerun all of those queries it stored and compare the new hashes against the old hashes. And so if any of those queries changed, it'll mark them internally as pending revalidation. Finally, our server spins up a headless browser, and it navigates to the user's website with some specific search params, which our toolbar can pick up and call a revalidation. So this all happens, as I showed in my demo, pretty fast. There's quite a lot of things happening, but it's not complex for users to set up. This is kind of what happens in the toolbar component. It sets up a server action, and when it's called, it calls get CMS pending tags or some function like that. And for each of those tags, it calls Next.js's revalidate tag. In the toolbar client part, it basically gets the search params, and it calls this server function as the search params get resolved. Yet again, our developers don't have to think about all of this, luckily. They just mount toolbar in their root layouts, and they should be good to go. So easy for developers to integrate, and very important for a good content editing experience. And all of that is possible for us thanks to using more of the React platform. Last but not least, we have branching. BaseHub is one of the only, if not the only, CMS that has Git-like branches of content. So when working on new content, users can toggle between branches, and with the help of pump and toolbar, everything will just update in real time as you'd expect. So this is a little demo following up from the website we've seen in this talk. We have the currently published website, full screen, and we can go to the bottom right, over to the toolbar. We can see the branches, and we can switch to a new branch. And this is React Miami if it was green. So maybe it's probably more expensive, and it has like more features and plans and whatever. And we have some FAQs down there. And all of this, it's just an experiment. We can toggle it back off and hopefully go back to beautiful pink React Miami, which looks actually much nicer. And this helps editors of this website, of this hypothetical website, just preview and try out different options. This helps for landing pages, but it also helps for blog posts. Maybe one of your colleagues saw a blog post and they wanted to suggest some changes. They can create a branch. Don't bother with the piece that you are creating, and tell you, hey, this is my suggestion. You can preview it, and it should all work. This is much simpler, fortunately, because we already have pump. We already have toolbar. We kind of already have the foundational pieces to create this feature inside the website. Let's kind of explore, again, how this could be built, maybe thinking about the old paradigm. We have a simplified implementation. We have a hook called use branches. We somehow fetch branches from our CMS with get CMS branches in that use effect. And we store them in a use state. There's not much to it, but in this case, I want to highlight the authentication story of all of this. In my previous examples, I kind of skipped over what about authentication, like those server actions are available for anyone that kind of wants to hack it over. But we can pretty easily, like this slide shows, how do we make a request to the CMS branches? We kind of need a token, but we don't want to make the token public. Maybe our system, our CMS, has like a public token that has fine-grained access. That's just odd to configure for both the platform and for the developer. And so this is actually quite easy with server actions. In this case, the interaction starts from our system, from basehub.com. Users click preview. Whoa, that was a great sound. Is this me, by the way? Hope it's not me. Users start from our editor. They click preview, and preview takes them to the website, the end user website, with a JWT or a token, which is called, we call it a preview token. And toolbar can then store it, save it in something like local storage or something like that, and send this over to the server actions that it got provided. So if it needs to get branches, it will send over the preview token, making sure that everything is authenticated And that's another problem solved by this pattern. And that's branching. It's, again, awesome to be able to provide this kind of developer experience, also this kind of editor experience, because we kind of juggle between these two user personas, I guess, all the while managing a lot of complexity and hassle ourselves. Actually, this couple of components and patterns just manage it all for developers. And it's all mostly thanks to us using more of the React platform. So yeah, I encourage you to use it more yourself, to try out weird patterns. And yeah, thank you for listening. And you can see the talk links in there.